Solve the equation in indices. 1 over 4 of 64 raised to power x equals 16 raised to power 2x. We want to bear this basic principle of indices in mind on the right hand side. A raised to power minus n is the same thing as 1 divided by a raised to power n. And so that means that 1 over 4 we have here, we can actually change it. We can make it 4 raised to power minus 1. And the of is multiplication sign, that is times 64 raised to power x. We can break it down to become 4 raised to power 3, and then x can be added based on this principle by the right hand side. Okay, so we have 16 raised to power 2x. We can actually break it down into 4 raised to power 2, and then let's open a bracket, 2x bracket close, which is the same thing as what is applicable in the second principle. 2 can be multiplied by the exponent 2x. So let's continue. Now we have 4 raised to power minus 1 times 4 raised to power 3x. We can apply another principle, which means that 4, which is one of the 4s, and take one of them and say minus 1 plus 3x equals to 4 raised to power 2 times 2 gives us 4, and that is 2 times 2x gives us 4x. Right, so based on the law of indices, we can actually cross out this. So this has eliminated this. What is left here now is 3x minus 1. We have minus 1 plus 3x is the same thing as 3x minus 1 equals to 4x. Then we can take the unknowns to one side of the equation and the known number to the other side of the equation. That is to say 3x because so we say 3x, 4 going to the other side of the equation will become minus 4x, and 1 which goes to the other side of the equation, 1 will become plus 1. So we have positive 1 here. So at this stage we have 3x minus 4x will give us minus x, that is 1x, and we have 1 left at the right hand side, which is the same thing as x equals to -1, and that's our final answer. Okay. Simplify 0.125 raised to the power 2 all over 3. What do we do in this case? We can simply change 0.125, we can change it to a proper fraction, from decimal to proper fraction, which is 1, 2, 5. We have the decimal to be 1, and we have 3 digits after the decimal, that will be 1000. Now is raised to power 2 over 3. Okay, so the next thing we can do now is, following the principle of indices, 2 over 3, we can actually say find the cube root. The 3 in the denominator is now written here as cube root of 125 over 1000 then we can put it in brackets raised to power 2. So the cube root of 125, cube root of 125, that is 5. Remember, 5 times 5 times 5 will give us 125. Let's write it here. 5 times 5 times 5 will give us 125. And then we also know that 10 times 10 times 10 will give us 1000. So the cube root of 1000 here is 10. Meanwhile, we still have raised to power 2 here, raised to power 2. So which means 5 raised to power 2 will be 25, 5 raised to power 2, and we also have 10 raised to power 2, which is the exponent here. The power we have here is what we have added here to 5 and to 2. So 5 raised to power 2 will give us 25, and then 10 raised to power 2 is 100. And then our final answer, 25 go it itself 1, and 25 in 100 is 4. With this, we have simplified the exponent.